This research paper introduces a novel framework, MobAgent, for generating realistic travel diaries at an urban scale, incorporating individual profiles and mobility patterns. The framework leverages large language models, LLMs, to understand individual mobility behavioral differences and generate personalized trajectories conforming to real-world contexts. MobAgent consists of two phases: understanding-based mobility pattern extraction and reasoning-based trajectory generation. The first phase extracts reasons behind specific mobility trendiness and attribute influences, providing reliable patterns. The second phase infers relationships between contextual factors and underlying motivations of mobility, generating more authentic and personalized mobilities that reflect both individual differences and real-world constraints. The authors highlight the limitations of existing deep learning methods, such as VAE, GAN, and diffusion models, in understanding the intentional and contextual aspects of human mobility. They argue that LLMs, with their emergent abilities for semantic interpreting and general-purpose reasoning, can simulate human behaviors with a narrowly defined context. The proposed framework is evaluated using GPT 4.0 and DeepSeek APIs on a 0.2 million real-world travel survey data with individual profiles. The results demonstrate that MobAgent excels in generating personalized and context-aware travel diaries over the space-time and semantic scale. The authors contribute to the field by revealing the dependency between individual attributes and mobility behaviors, introducing an understanding-based patterns extraction mechanism, and proposing a reason-based rethink strategy that generates interpretable motivation and mobility. Recent advancements in machine learning, particularly in generative models such as VAEs, GANs, and DDPMs, have improved the generation of realistic human movement trajectories. However, these models often struggle with interpretability and sensitivity to contextual factors. The integration of statistical models and deep learning models has been proposed as a more robust framework for capturing the complex, multidimensional nature of human mobility. Additionally, large language models, LLMs, have been leveraged to replicate real-world dynamics and generate believable behavior, simulating human decision-making in fields such as epidemiology, sociology, and economics. The problem definition involves generating realistic individual travel diaries, which are sets of location-based trajectory point sequences, including spatial location, visit time, travel purpose, travel distance, and travel mode. The goal is to learn realistic individual mobility patterns to generate new travel diary data that has similar characteristics and mobility patterns as the real-world travel survey dataset. The proposed framework consists of two progressive stages: understanding-based mobility pattern extraction and reasoning-based travel diary generation. The first stage involves dividing individuals into fine-grained groups based on multiple individual profiles and then creating subgroups through hierarchical clustering. Large language models are employed to preliminarily extract fine-grained mobility patterns and generate explanations to construct contextual knowledge of human mobility in the real world. This allows for observing more specific and personable mobility behaviors and avoiding the pitfalls of averaging out individual differences. The understanding-based mobility pattern extraction stage involves identifying patterns and reasons for each subgroup, and then analyzing and evaluating the extracted patterns and reasons. This stage involves thinking why an individual belongs to a specific group, evaluating the masked context, and updating patterns and reasons. The output of this stage is a set of fine-grained mobility patterns and differences, which are then used in the reasoning-based travel diary generation stage to generate new travel diary data that has similar characteristics and mobility patterns as the real-world travel survey dataset. Here is a combined summary of the 4 pages. This paper proposes a novel framework for generating realistic human mobility behaviors using large language models, LLMs. The approach leverages LLM's capabilities to simulate human-like thought processes and understand underlying mechanisms driving individual mobility patterns. The framework consists of 2 main components: pattern extraction and reasoning-based travel diary generation. In pattern extraction, key aspects such as travel time, frequency, preferred travel modes, intentions, and common destinations are identified and analyzed contextually to understand the underlying reasons behind observed mobility patterns. The reasoning-based travel diary generation phase uses retrieval augmentation to provide additional information, aiding the LLM in responding to queries. A self-evaluation workflow based on the chain of thought mechanism is constructed, where the LLM infers the group an individual belongs to and completes masked information in personal travel diaries. The generated semantic mobility is mapped to a real urban environment, considering attributes such as socioeconomic status, personal preferences, and lifestyles. Experimental results validate the effectiveness of the proposed framework, demonstrating superiority over other abolition models in terms of statistical and semantic dimensions. Ablation experiments on the office staff group divided by attributes such as age, income, and occupation show that integrating all three dimensions yields optimal performance. Spatial temporal analysis explores how individuals' attributes affect their mobility choices over space and time scales, with illustrative examples demonstrating the effectiveness of the proposed framework in capturing relationships between individual attributes and travel diaries. This research, spanning pages 9 to 12, delves into the integration of detailed individual and travel data into agent models to enhance mobility and travel behavior predictions. The authors emphasize the importance of using finer-grained data to simulate real-life scenarios, employing methodologies such as diffusion models, generative adversarial networks, and trajectory generation frameworks. They underscore the significance of understanding individual human mobility patterns and their associations with mobility behaviors, highlighting the role of large language models in simulating human mobility and behavior. The dataset originates from a survey on social networking platforms, focusing on volunteers' travel trajectories. It includes detailed personal background information and travel records. The distribution of user profiles shows a significant proportion of participants aged 18–30, with males dominating the dataset. Occupations range from management to students, with a majority in the commercial and service industry. Income levels are diverse, with a slight majority in the low to relatively low categories. Educational backgrounds vary, but most participants hold a bachelor's degree or higher. The dataset is predominantly from Shenzhen, with data collected over a few months in 20,162,017. It contains information on travel dates, origins, destinations, modes, durations, distances, and purposes. The goal is to uncover the diversity in human mobility behaviors by initially classifying subjects based on age, gender, occupation, income, and education. The need for further segmentation is considered, with a rating system suggesting a strong recommendation for additional segmentation. The patterns of travel behaviors are analyzed, focusing on correlations between attributes and travel behaviors. Daily plans are generated based on mobility patterns, and the motivations behind activities are inferred. The dataset provides a comprehensive framework for understanding human mobility and behavior.